Okay, solving quadratic equation by the square root principle, square root method, completing the square. So we'll start with an easy one to begin with, right? Or just a almost trivial one. Let's start with something trivial. X squared equals 9. What's x? Plus or minus 3. Okay, so important to remember when you are taking the square root, how do we solve this? We take the square root of both sides. When you do that, it's really plus or minus. It's really plus or minus on both sides, right? But it's redundant to go plus or minus x equals plus or minus 3 because every way we combine it, it only comes out to two possibilities, right? X is equal to 3 or x is equal to negative 3, okay? So, big deal though, right? It's a big thing, is that we must take the square root of both sides. So what we need to do is we need to isolate the thing that is being squared, okay? Which may be just an x or it may be an expression. So we want to isolate the thing that's being squared and then take the square root of both sides. All right, so maybe it looks like this. X squared minus 21 is 123. Now you got to do a little work. What's the first step? Add 21. What do we get? X squared is 144. What's x? Plus or minus 12, right? Biggest thing, plus or minus, right? What are you going to forget? You're going to forget the minus. You're just going to do a plus. You're going to lose all kinds of marks. You could also do it this way, right? Or you could go x squared minus 144 is equal to 0, and then factor that as a difference of squares.
So much longer.
Yeah, which is, but that's so yesterday, and this is today, so. Okay, we'll just. All right, but what does it really look like? I mean, you know, what are we really going to solve? Stuff like this, maybe. X plus 2 quantity squared minus 25 is equal to 0. Okay. Now, you could expand that, right? Get x squared plus 4x plus 4, and then you could combine it, get x squared plus 4x minus 21, and then you could factor it. Okay, but there's an easier way, right? An easier way than expanding and factoring. Generally try and avoid expansion if you can, especially when you have a thing that is being squared. So instead you say, let's isolate the thing that's being squared. Or I suppose we could call it an expression. But let's isolate the expression which is squared. Now what? Now we take the square root of both sides. What's the square root of x plus 2 quantity squared? Just x plus 2. What's the square root of 25? No, already. Jeez, how many times have I gone over this? Hey. Wait, here's the sound of me banging my head into a wall.
It's a lie.
Okay, I know, but the head might hurt. Okay, what's x? Right, so it's negative 2 plus or minus root 5, which is going to yield us two solutions, which are negative 7 or positive 3. Okay? So generally speaking, most of the time you're going to get two solutions, right? Not always. Sometimes you get one, sometimes you get none. And you know, we'll be going through cases. Why is that? How do I know if I'm going to get one solution or two solutions or no solutions? What does that look like? Okay, but we got ways of doing that. Okay, so, right, that's kind of basic stuff, right? Let's go on to something a little more complicated. So what we're going to do now is complete the square. In order to solve. Okay, so pay attention. Although you can replay this, you know, if you need to. Because what's going to happen up here is I'm going to work on a couple of lines. Like I'm going to go down to this line and do something, then come back up to another line, right? Which on paper, which is static, you don't really know what happened, right? All you see is the final product, and there's just writing on both lines. You don't realize that, well, we went here, and then we came back up here and did this. Okay, but on here, you'll be able to see that. All right, so here's the problem. X squared minus 10x plus 23 is equal to 0. And the problem is, does that factor? Well, the question is, does that factor? The answer is 23 is prime, so the only factors are 1 and 23, which would give me a middle term of 22 or 24, positive or negative, but not 10. So we cannot factor this. All right? So what we're going to do is a method called completing the square. Okay, and here's how it works. First thing we're going to do is we're going to write x squared minus 10x, leave some space, equals negative 23. Okay? So we move the 23 over, right? So we have the x squared and the x term on the left side, and we have the constant term on the right side. Now what I want to do is I want to make a perfect square trinomial, because it'll factor. Remember previous example, we had x plus 2 squared, right? Which is actually x squared plus 4x plus 4. So if I had originally x squared plus 4x plus 4, we could factor that to get the x plus 2 squared and then solve from there. So what I want to do is get a perfect square trinomial, something that factors. So here's how we do it. We go x. So I want something that's going to square, right? So what do we do with the 10? We take half of the 10. We get x minus 5 squared, which is going to be x squared minus 10x plus 25, right? So this is where we go from one line to the other. Okay? So I come down here, I write the x, I put this sign, minus, because I need the minus. I take half of this, 5, write that. Okay, when I do this, x minus 5 squared, I now come back up here and add 25. If I add 25 to the left side, I also must add 25 to the right side. Keep things in balance. Okay? So now this side is now this, right? X squared minus 10x plus 25 is x minus 5 quantity squared. And what's this side? 2. And now how do we solve this? Take the square root of both sides, right? Giving me x minus 5 is equal to plus or minus, very important, root 2. So what's x equal to? Okay, so let's put the 5 first. So we're going to go 5 plus or minus root 2. We've got to put the 5 first because we want that plus or minus. We don't need to list these as two separate solutions, right? You're allowed to just say 5 plus or minus root 2. We do know that there are two solutions, right? One of which is x is equal to 5 plus root 2, and the other one of which is x is equal to 5 minus root 2. Those are exact. Right? Exact solutions, either numbers. I mean, the previous solution was exact too, right? 3 and negative 7 are exact. But here, this wouldn't factor, right? Can't factor that. So we solve by completing the square. Right? And you've now got the method, and we'll do a couple more. Okay. Ready? Everybody good with this? Yeah. Okay, remember we're working on 2 lines, right? We start here, we go down to here, we come back to here and fill it in. Okay, let's do another one. 2x squared minus 5x. Okay, so there's a nice standard quadratic, ax squared plus bx plus c is equal to 0. It's not factorable. Okay, doesn't factor. We want to solve it. Okay, so what do? First step?
Move the 17.
Yeah, we're going to move the 17 over, right? Now, here's the problem. I cannot do completed square on a 2x squared. I need to do it on an x squared. So we're going to have to get rid of the 2. And the way we're going to do that is we're going to divide everything by 2. Okay? Not going to factor it out. We're just going to divide everything by the 2. Okay? And we know that stuff is going to fill that in. And we're going to figure out what stuff is going to fill that in a second. So now we come down to the next line. we go x minus, we take half of 5 halves, which is 5 fourths, 5 quarters. And we're going to square that. Now we come back up and fill in this line. So what is 5 over 4 squared?
25 over 16.
25 over 16. And what do we do over here? You do the same thing, right? So what is this equal to? What is 8 times 17? 136, 141, 161 over 16, right? I don't know, check it out. Maybe it is, maybe it isn't. So we need a common denominator, right? Which is going to be 16, and 17 over 2 is, I believe, 136 over 16, plus 25 gives you 161 over 16, yeah? Okay, we have independent verification. Let's continue on. Now what?
Take a square root.
Take square root of both sides. Now 16, having a square root, we'll just call it 4, and then the 161 is just plus or minus root 161. Should this simplify, you have to, right? In other words, you got to express it as a mixed radical. Okay, and then do any cancellation. Oh, we're not quite done, so we got to add the 5 quarters, right? So it's 5 quarters plus or minus the root of 161 over 4, at which point you say, well, hang on, they've got a common denominator, so why not just write it as 5 plus or minus root 161 all over 4? And there you go. There's your answer. Okay?
No, it isn't.
Easy peasy. Now, should the 161 reduce, right, or then maybe, and then you would have to have a common factor in all 3 places, right? Here, here, here. So if there was like a 4 here, a 4 here, and an 8 here, I could divide everything by 4. If there was a 6, a 4, and a 2, I could divide everything by 2, right? But it needs to be a common factor in all 3 places. In this case, there is nothing, so that's it. It's done. That's all there is. That's all he wrote.
Lesson's finished.
No, I could do a couple more. Can't hurt. We'll just do this. Well, you do it. Okay, I'll write it down and you do it. X squared plus 8x minus 5 equals 0.
Jan over.
So,
I have a question.
what?
Nothing.
Ooh. Yes.
In what form do you want our answers to be in? Do you want our answers to be in?
The last one I wrote. 5 plus or minus root 161 over 4.
So it doesn't have to be
The most simplified one.
With an equal sign preceding that and an x preceding that. No, you don't need 2 separate answers, right? With a plus or minus, you would almost never write 2 separate answers. Okay? Unless for some reason it had 2 separate blanks or something. When we get into real life stuff, you may be rejecting answers based on, well, 5 minus root 161 over 4 is negative. If I was trying to work out the width of something, then I would reject that and just give a single answer, right? Because I'm not going to say, oh, the width is negative, 5 minus root 1. And maybe occasionally we might ask for it rounded to 2 decimal places or something, right? But then there's other techniques that'll do that as well. Okay? So, do this. I will give you a head start, and then I will just lag behind a little, and I will do this as well. So I just think about the steps. Am I ahead of you already? No? Good.
That's how I want to do it. That's okay. That's okay.
8 divided by 2 is 6.
I should make a mistake just on purpose one of these times.
You should.
As opposed to the ones I make not on purpose all of the time, but.
Did you?
Okay, good. Yeah? Checks? Everybody's happy? If this kind of stuff makes you happy, then you're happy. Okay, let's do one more. I mean, before you then go and do 100 more because the homework,
Oh, God.
Is that 16?
Is that 11?
Oh, sorry, that's an 11x.
That looks like IB.
That, yeah.
Artifacts everywhere. Oh god.
No.
Or what? We could say this.
Oh yeah, why?
IB or not IB.
Isn't that?
Oh yeah.
It's a union. Union is the or because it adds everything together.
We already went through this.
When I learned this stuff, it was with the union and the intersection sign, and then when I taught this stuff, it was always with the word and or. And I kind of prefer and or, so I always have to translate that. Okay, that's or.
3x
Something goes circle.
Okay, follow the procedure.
It's okay,
I'll give you a bit more of a head start. You can actually kind of sort of skip ahead a bit, right? So we can isolate and divide by 3 all at the same time. Ooh. Sure. So it's like walking the tightrope without a safety thing.
What's 11 over 6?
121 over 36.
Oh, I just realized something. Oh, right. That makes sense.
Math.
6 squares.
Oh wait, that's 48. That's
I just
106.
realized how hard it is to write. Otherwise that happens.
Yeah. If these ever work out to nice numbers, it means that this thing would have factored.
Yeah.
Ooh, that's weird.
Yep, got it.
Alright, great. Yeah. What?
It's like divided over 6, except 11 over 3.
No, you moved it over it's into this.
What?
What?
What are you saying?
11 over 6.
Yes, I did.
I don't know what it was.
Because I'm supposed to.
Oh,
Because I'm taking half of 11 over 3. Right? That's what goes in here. Half up. When I square root both sides, the brackets in the square just drop away. Yeah. Is this good or bad? It's good. It's good? You see it? Yeah, you good? Yeah. Yeah, square root of 169 is 13. Yeah.
Can we go further?
Go further.
Like minus 11 over 6, minus 13 over 6.
Yeah, you could go like minus 24 over 6, which would be like negative 4. And you could go x is equal to what? 2 over 6? 1/3. So wait. If x equals 1/3 is the root, what's the factor? Can't you go from roots to factors?
Yeah, you can.
Okay, so x equals 1/3 is the root. What's the factor?
3x.
So x equals 1/3, so 3x equals 1, so 3x minus 1 equals 0. And we got x equals negative 4, so x plus 4 equals 0. So the factors are 3x minus 1 and x plus 4, which give us 3x squared plus 12 minus 1 plus 11x minus 4. Ah, could have just factored the silly thing.
Woohoo, I went.
We are so good.
All right, look. This is how you know if it would have factored.
After you
No
get the
radicals.
of course.
Right, yeah.
No radicals means we have actual solutions, right? Maybe they're fractions, but so what? 1/3 You know, the root is 1/3, the factor is 3x minus 1. The root is -4, the factor is 4. You all get that, right? You all understand how to change roots to factors and stuff? All right, so hey, look at that. It would have factored. Okay? But hey, sometimes you're doing a problem and you just can't see what the factorization is, right? And that's fine. So you do it this way and you solve. Okay, any questions? All right, we still got a couple minutes. Yes.
Is there another way to do
There's a negative one.
No.
it? Have to use factors.
Yeah. Yeah. No.
So I see can you
No.
yours?
All right. So it also says on the sheet, introduction of the quadratic formula.
I'm gonna write it down just in case I forget.
Oh, quadratic formula.
Okay.
See, I'm never gonna prove it if I'm
No, you're gonna do it. Do what you just did to this.
prove it. It's essential.
In other words, well, it's derive it really. Derive the not that kind of derivative. Derive the quadratic formula.
Yeah, I know it's that.
So then, how do we know if the x equals 1 or not? Then can't we? So we
No,
have to do that
okay,
separate thing.
what?
Oh,
You derive that you keep x as x.
oh.
Right?
You're not, yeah.
So what do we do? Well, we isolate the constant term on the right side. We divide by the leading coefficient. We then write down our factorization, right, or our perfect square. So this will be 2a, because half of b over a is b over 2a, right? We then square that, giving us what? Yes, the square of that. When you square something, you do indeed get the square of that. And we have to add that to both sides, right? B over 2a times b over 2a is b squared over 2 times 2 is 4. A times a is a squared. Yeah? Common denominator. I'm going to go over here to help me with this. So I need a 4a squared. So there's going to be a 4a times a 4a. So negative 4ac over 4a
Yeah,
squared.
exactly. But there's less step. You have to write it. That's why you Oh no. Okay, this method is the same as this, right?
Only that's kind of, you know, I got a negative there. So I'm going to flip this around. So, so we take the square root, we get b over 2a, and we're going to get plus or minus the square root of, and I'm going to go b squared minus 4ac. What's the square root of 4a squared?
2a.
2a. We're not being Canadian here going 2a. No, it's 2a. And combining.
Finish lesson.
Lesson's over?
I don't know. I think this is half of tomorrow's lesson.
Oh, why?
Let's just do finish the week. We'll finish the week today, and then we're done, and you just have homework. No.
Yay.
All right. Yes. Okay. Here's how you memorize it. You sing it to the tune of "Pop Goes the Weasel."
Or you just memorize it.
Or you just memorize it.
Now. All right. You ready? All together now. Okay. So to the tune of "Pop Goes the Weasel." X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. A doesn't make sense. Oh, you're weak.